This this one is the last video and last topic of periodic table class 11. The topic is valence and oxidation state and their periodic trends. Here the first one is definition of valence. The actual combining capacity of an atom is called valence. It represents the number of chemical bonds, covalent bond or ionic bond, an atom forms with other atoms to achieve a stable electronic configuration. To achieve a stable electronic configuration, an atom of an element forms bond as many as that number of bond which is formed by an atom of an element in a molecule is called its valence. Valence of representative elements such as S block and P block elements is usually equal to number of valence electron in the outermost orbital and or equal to 8 minus the number of outermost shell electrons. For example, carbon is an element of group 14 and it is an element of P block. Its atomic number is 6. So the configuration of carbon may be helium, which is core, yani 1s2, and 2s2, 2p2. Now, to complete octet or to complete the nearest noble gas element, that is neon, each carbon atom requires 4 electrons. If I shall draw the orbital of valence shell, then carbon has 1 orbital in S, 2s and 2p. There are altogether 4 orbitals in the outermost shell of carbon, and each carbon atom in its excited state has 4 half-filled orbital. So carbon forms 4 bond, or better to say, since there are 4 electrons in its outermost shell, its valence is equal to number of electron in outermost orbit. See, in methane, each carbon atom forms 4 covalent bond. Even in ethane or any other organic compound, you will find that each carbon atom forms 4 bonds. So valence of carbon is 4, which is number of outermost electrons. Similarly, if we take another example, for example, lithium, sodium, or hydrogen. Hydrogen has 1 electron in outermost shell, so its valence is 1. Take another example. For example, if you are considering the case of elements of group 16 or group 17, that is the case of oxygen or fluorine, like that element, then suppose we are taking example of oxygen, its configuration is helium 2s2 and 2p4. So altogether there are 2p4. altogether there are total electron in valence cell. Electrons in valence cell is 6. But oxygen forms compounds of oxygen H2O. That means each oxygen atom forms 2 bond. Even OF2, each oxygen forms 2 bond with fluorine also. And in most of the cases you will find each oxygen shows only 2 valence. So valence of oxygen is 2. Then here in this case, at least in case of oxygen, the valence is not equal to number of electrons in valence shell. It is equal to, valence is equal to 8 minus 6, that is 2. What is 8? 8 is octet. It is the outermost electronic configuration of noble gas elements. So therefore it is said that the valence of element, number of electrons in the outermost cell, or 8 minus number of outermost electron. Now I think every student must understood what I have written or what I have explained. Okay, so now come to the next point. What is oxidation number? Example of valence. I think everyone got this point. Okay, so now the oxidation state. What is oxidation state? Oxidation state, the hypothetical charge given an atom in a molecule or ion considering breaking of all bonds with different atoms attached on the basis of comparison of electronegativity is called oxidation number. Oxidation number is charge. It is not only number, it is number of charge. So number of charge, how much? When you are subtracting, when you are isolating all the atoms. For example, take example H2O. Okay, in H2O, hydrogen is less electronegative, so it should be plus, and oxygen should have minus. Similarly, here also hydrogen plus and oxygen minus. So oxidation number of oxygen is minus 2, and oxidation number of each hydrogen is plus 1. Okay, take another example. Example number 2. If you are taking the example of OF2, we all know that fluorine is more electronegative than oxygen. Then fluorine has 1 minus, oxygen has plus 1. Similarly, here minus 1 and again minus 2. So oxidation number of oxygen is plus 2, and oxidation number of each fluorine is minus 1. So oxidation number is number of charge. It is formal charge. It is imaginary charge given to each atom of an element when it is considered that the atom is isolated from other atoms with which it is attached in a molecule on the basis of electronegativity comparison. So I think a student could understood what I have explained here. Okay, now next. So here till this time we understood definition of oxidation number and definition of valence. Now let us consider some important points regarding oxidation number and valency. To distinguish between the two, sign positive or negative, when we are considering the valence, it is a pure number and never has a plus or minus sign. In valence, there is no plus sign or minus sign. So, however, when we consider plus sign or minus sign, it will be oxidation number. Take example. In methane, CH4, valence of carbon is simply 4 and valence of each hydrogen is 1. But when we will consider the charge, when we will consider the oxidation number, we have to write separation of atom from each other on the basis of electronegativity comparison. Hydrogen is less electronegative than carbon, so carbon must be -1 and hydrogen should be +1 in each bond. So here it is 1, here it is 1 and here it is also 1. But how many carbon has how much charge? It has total -4 charge. So oxidation number of carbon is -4. Oxidation number of each hydrogen is +1. So that is the difference. Oxidation number and valence are two different things. Valence is pure number and oxidation number is charge, formal charge. Now point number two explains that is fraction or whole number. Valence will never be the fraction. Valence will always be whole number, whereas the oxidation number may be fractional. For example, take example in azide N3H, hydrogen is +1, but each nitrogen oxidation number of nitrogen is equal to -1/3. That is the fraction. So depending on the case, it may be oxidation number may be fractional, but valence will always be whole number. Now third one, 0. Valence, an element's valence is rarely 0 except for noble gases. And noble gas has valence and 0 valence because other than helium, all noble gas have octet, a stable configuration, and they do not combine with other atoms of other element. So in case of noble gas, valence may be 0. But oxidation state of any element in its free state or uncombined state will be 0. Suppose if we are considering the oxidation number in O2, both of the oxygen atom have same electronegativity, which should be given minus, which should be given plus, none. So in that case, the oxidation number of each atom is 0. Similarly in H2, similarly in N2, or such type of molecules which are free or same atomic molecules. In that case, what is the oxidation number of iron in free state? You will find the oxidation number in all these cases is 0. These are the points we must understand. So, and next, here we have taken some representative element, group 1, group 2, 13, 14, 15, 16, 17 and 18 element. Their valence, if we are considering the valence, then here a group element of group 1 will have the valence 1, group 2 is 2, group 3 3, group 13 elements should have 3, group 14 elements should have 4. But thereafter, if we are considering the element of 15th group, then in some cases it will be the valence will be 3, but in some cases it may be 3 and 5. Similarly, element of 16th group, for example, oxygen, sulfur, selenium, tellurium, will show the valence of 6 as well as 2. In most of the cases 2, but in some of the cases, in some of the molecules, they will show the oxidation number up to 6. In case of noble gases, it will be 0 or even maximum 8. So this is the this understanding must be to each student. Here we are considering some important properties of elements at a time in a periodic table. Suppose atomic radius and ionic radius. So atomic radius and ionic radius decreases from left to right in a period. Ionization energy also increases from left to right. That means the leftmost element, alkali metals, have the lowest ionization energy, and elements of group 17, that means halogens, have highest ionization energy. So ionization energy increases from left to right. Metallic character decreases, but non-metallic character increases from left to right. Valence increases then decreases. Valence from group 1 element, that means leftmost, increases up to 13th or 14th group element, that means in up to middle, and thereafter it started decreasing. So these are the property we should learn from periodic table. It will, all these information will be very important in other chapters when we will discuss the points from in other chapter. These property will be very useful for us. Now last, the chemical reactivity of element can be best shown by its reaction with oxygen and halogen. Here we shall consider the reaction of elements with oxygen only. By considering the reaction with oxygen, we can understood the reactivity as well as valence of elements. Element on two extremes of a period are easily combined with oxygen to form oxide. Let us consider the leftmost is alkali metals, that means lithium, sodium, all these are the elements of group 1 in periodic table, that means leftmost elements, and their oxides are Li2O or Na2O. In all these oxides, the nature of the compound ionic. All these compounds are ionic in nature. Extreme left most basic, and these are basic also, these basic nature. Whereas when we will considering the elements of 17th group, it is group 1 element, and we are considering 17th, that is fluorine, chlorine. Then we will find the Cl2O7 compound. Cl2O7 is acidic in nature. acidic in nature. If we are considering the elements of group 13 or 14, 13 or 14, that means boron and aluminum, all these are the elements. Then we have to take Al2O3, and Al2O3 is amphoteric in nature. Amphoteric. That means these compounds react with acid as well as base. So what is the main point? What is to understand now? We should understand that leftmost oxides are basic, rightmost oxides are acidic. It means the the properties of oxides from left to right, starting from basic nature and end at acidic nature. That means basic nature decreases gradually and acidic nature increases. But in case of middle element, that means aluminum, carbon, all these sodium, aluminum, carbon, these elements, their salts, their oxides are generally neutral or amphoteric in nature. Here that is given. Oxides of elements in center are amphoteric. Amphoteric oxides behave as acidic with base and as basic with acid, whereas neutral oxides have no acidity or basic character. So these important points we must learn from periodic table. And at last, let us look at some compounds of the elements in periodic table. They are hydrides. Group 1 elements, lithium hydride, sodium hydride, potassium hydride. Group 2 element, calcium hydride. Group 3 element, B2OH6 or ALH3, and 14 CH4, SiH4, वगैरह. Up to 14, what happens? Actually, in these oxides, valence equal to number of electron in their valence shell. However, when we are considering elements of 15th group, that means NH3, PH3, AS3, you will find the valence is equal to 8 minus group, 8 minus 5, that is 3. And in case of 16th group element also, the valence is 2. How it is equal to 8 minus 6, and so on. So up to this point, we understood the nature of oxides, valence and oxidation state. Thank you.